So now we have the carboanions. They are actually a carbon with the negative charge. They are actually carbon with a negative charge. So as I told you that it is also again formed as a result of heterolytic fission. That means the fission occur in such a way that one takes away the electron and the other is deprived. And we have already studied the one which is deprived is carbocation. You know that how it is formed actually, or what kind of the stability, how you can explain the stability. So coming on to carboanion, it is the carbon which has the negative charge. That means it has the it has taken away the shared pair along with it, right. So this is what is the carboanion. So now if we talk of the stability, then its stability is actually reverse of the free radical and the carbocation. It is stable something like in this order. That means methyl group is more stable, this methyl is more stable, and the 3 degree is least stable. So again it can be explained on the basis of inductive effect. As I already told you when we were discussing carbocation that the alkyl groups actually show plus I effect. They have the electron releasing tendency. So what happened that whenever they are attached to this, for example, I will take an example first. Suppose I have this kind of thing and here I have this is my carboanion. So now as we know that in this case there are 3 methyl groups. And we know that they have electron releasing tendency. It can release an electron, it can release an electron, it can release an electron. So this will actually not help in the dispersal of charge, or otherwise you can say it will increase the magnitude of the negative charge. And something which will increase the magnitude of the negative charge or which will delocalize the electrons, it will just you can say suppress the stability. So that is the reason, because here it has 3 alkyl groups. That means the 3 groups which can actually donate the electrons, and by donating an electron they are just intensifying the charge. That means they are increasing the magnitude of the negative charge. So that means it is something the least stable. So as far this is concerned, here is no alkyl group. That means the least plus I effect is seen. So that means the charge is not going to increase, it will remain as such. So that means out of them if we compare, this will be more stable, right. So now we can have the carboanions from the alkynes, we can have the carboanions from the alkenes, we can have it from the alkynes. So just look at their stability. So let's say that this is my alkyne carboanion. It is more stable than the alkene one, and it is the least stable. Now as we know that in the alkynes it is sp hybridized, it is sp2 hybridized, it is sp3 hybridized. So as we know that if we compare the S character in them, so it has maximum S character and it has least S character. And we know S are pulled, they are actually present closer to the nucleus, so they are pulled with a greater force. So that means the S, the one which will have the more S character in it will be pulling it more towards the nucleus, and their negative charge will somehow get neutralized because nucleus is positively charged. So that is why it corresponds to the more stability. So out of them this has the S character maximum, so that will be will be more closer to the nucleus, and its negative charge will somehow be dispersed, and by this we can say that this is more stable carboanion which is obtained from alkynes, and the one which is obtained from alkanes is the least stable Now coming on to the next the intermediate, that is the carbene. So what is carbene actually? Carbene is the organic compound or a species in which the carbon has sextet of electrons. It does not have any charge, it has a sextet of electrons, right. So for example, we have CH2N2, so it breaks in this way that we get a carbene. So this is our carbene. You can see that here how many electrons it has. It has bonded with 2 hydrogens, that means 4 electrons already and 2 more, so 6, but it does not have any kind of charge on it. So that is something called as carbenes. So now one more thing I would like to discuss with you, like we have done the carbocations, that is the carbon with the positive charge, we have done the carboanions, carbon with the negative charge. So do you think that what kind of reactions, do you have any idea that what kind of reactions they can undergo actually? So if we talk of the carbocations, because they have the positive charge, so that means they can be attacked by the nucleophiles. They can attacked by the nucleophiles because they have positive charge, and nucleophile are in search of positive charge, and positive one is looking for the electrons. So that means they can club them. They can club up, right? Second, what kind of reaction mode do you think that they can undergo? They can actually, you can say like this. Suppose I have a carbocation like this. Right. So what can happen? They can actually lose its proton. They can actually lose its proton, and after losing they will form a alkene. After losing they can form a alkene, any member of alkene, because here I took this thing, the ethyl carbocation, that is why it formed ethene. You can take any of it, will just release its proton and can form the alkene. Likewise, these cations can also, suppose I have this cation, they can actually react with alkene. They can actually react with alkene. So what happened? Because they contain this extra bond, pi electron, so this can open up and we can have as a result this thing. So it can form like this also. So that means they can add up into alkene, giving rise to alkanes. And moreover, we can observe the rearrangement occurring in the carbocations also. That means if it is 3 degree, it can transform into 2 degree, it can transform into 1 degree, just moving the, sometimes the alkyl group move, sometimes the hydrogen move. So it is called as the alkyl shift of the, or the hydrogen shift, just the movement of the positive charge. Like suppose if it is present on the corner one, it can move on to this middle one, it can move on in the entire chain. So that is something called as the rearrangement. So it's clear that carbocation can undergo a reaction with a nucleophile. They can actually being attacked by the alkene, or they can also lose a proton and can form an alkene, and they can undergo a rearrangement reactions, right? And coming on the nucleophile, likewise they are negatively charged, so that means they can react with the the negatively charged can react with the electrophile, and moreover they can show a type of addition and the substitution reactions. So now like we have already discussed these attacking reagents, we have discussed the intermediate, we have discussed the bond cleavage. So now it's time to look for the leaving groups, that what kind of groups that can leave actually, and then after this completing we can start with the type of chemical reactions where they all are going to function, and we are going to learn in a interesting manner that how the reaction actually take place and what kind of reactions do you encounter in the daily routine, right? So just look at the board.